three major properties of water that you should be aware of are surface tension, viscosity, and capillary action. Beginning with surface tension, we can see a cup filled with water. So as we remember, water molecules form hydrogen bonds. So let's take a look at this water molecule right here. What we see is that its hydrogen bonds are pulled toward the negative oxygens underneath it, and its oxygen is sort of pulled toward the positive hydrogens above it. The result is that it gets pulled in all sorts of directions and is kind of spread out. Now, let's look at the surface of the water on these top water molecules, We see that they are pulled down, their hydrogens are pulled down by these negative oxygens, but however, they are not being pulled up by anything. As a result, they can form a sort of tighter, compact shape. And this allows water to have surface tension. This can be seen when a bug walks across a lake, or when you put like blobs of water onto a penny and it sort of makes a bulge. An additional property of liquids that you should be aware of is viscosity. Viscosity is defined as a measure of internal friction, or in other words, thickness or a resistance to flow. There are three main properties that affect the viscosity of a liquid. These are the strength of the intermolecular forces, the temperature of the liquid, and the size and shape of molecules in the liquid. Let's say, to understand viscosity, we want to create a liquid that is super viscous and does not want to flow at all. Well, to do this, we need a liquid with high intermolecular forces. This is because the molecules in the liquid really want to bond together and are attracted to each other, and they really don't want to flow apart. The idea of temperature is kind of similar. If you increase the temperature of a liquid, they'll be more likely to flow and more likely to bounce around. So because we want a high viscosity liquid, we're going to lower the temperature. And the size of the molecules is a little bit more intuitive. If you have a bunch of large molecules with a lot of branches, they're more likely to get stuck, like their arms of the branches are likely to get stuck, and they are less likely to flow. So that means if we want a high viscosity liquid, we need to increase the size of the molecules. Another property of liquids that you should be aware of is capillary action. Capillary action is when water sort of crawls through another substance. An example of this can be seen when you have a puddle of water and you dip a corner of a paper towel into it. What will happen is the water will slowly crawl up the paper towels. And the reason this happens is because the water is attracted to the molecules of the paper towel more than the water itself. To illustrate this, I have drew a simplified version of this happening. So let's say we have the puddle of water, and remember this is a liquid, all the particles are moving around. So this water molecule, let's just say it moves and it bumps into this one, and it causes this one to bump into the paper towel. What will happen, because oxygen is very electronegative, it will bond to the side of the paper towel because it wants to take the electrons from it. And as a result, you'll get a little something like this, where water is stuck to the paper towel. Now let's say another water molecule comes, and it bumps off, and it bumps a little bit higher. What happens is that the water will slowly crawl through the paper towel, resulting in capillary action.